Yeah, that's great to see people waving back. I'm going to start in a couple of minutes, but I always like to take the first few minutes to get to know each other. That's a crazy crowd here. Thanks for coming today. I'm going to talk about a very controversial topic that's a little bit into psychology and stuff. And I expect every one of us today understand that we are actually human beings. Unlike what other people in our companies tell us, we have a very high degree of empathy, and I'm going to talk about that. So who are doing microservices? Raise your hand if you're doing microservices. That's great. That's a lot of hands. Yeah, it's definitely a thing right now. Raise your hands if you want to do microservices, that if you will, kind of. All right, that's basically the other half of the room. That's great. Yeah. So let me start with a brief introduction of who I am. I'm Armagan Amcalar. I come from Germany, Berlin. I work for a company called UNU GmbH, and we're building electric scooters, not the small toy ones, but actual motorcycles with batteries built in. And I'm basically leading the software engineering teams there. If you are interested in anything that I'm talking about today, we're hiring. We have a lot of open positions. If you're into microservices, Node.js, and everything JavaScript, I encourage you to look for what we have. I also lead a software craftsmanship school called Lonja. That's a software architecture school for women. And the idea is we try to encourage more and more women to pick up engineering and development jobs. Because as you see here within this room as well, there's a huge gap between representations, so we want to change that for good. And I'm also pretty much active on GitHub, so I have libraries that range from brain signal processing to backend frameworks, to front-end frameworks, to microservices frameworks, to playing guitar within a browser, and more. So I also encourage you to check them out if you are into open source programming. I want to start with what I'm going to tell you in the end. And it's a very famous quote, if you know it. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. This is a quote from a paper published in 1968. It's 50 years ago, and it's about software engineering, and it's about defining how we create software, how we create software architecture. And the underlying term is the architecture of the software represents the communication structures that we have within the team, within the organization, within the company. This is some food for thought. I want you to think about this for a couple of minutes throughout the presentation, and we'll basically get back to this soon. So let's also start with the roots. Why do we need code? Why do we write code? Or why do we need a programming language? Now, obviously, the goal is to create some sort of functioning mechanism, right, in terms of an application, maybe. And that serves a purpose that hopefully makes us some money so that we can make a living out of that. But that's not the answer. That's not the answer for why we need code. Because most of the stuff that we write, most of the applications that we write, run on machines, right? And machines don't work with code. Machines run with or work with electricity. So if we were able to produce electricity that the machines would understand, that would also work. And actually we'll do that with ones and zeros. Actually, that's what the compilers and the operating systems do. They convert our code into ones and zeros, into electrical signals that the machines can interpret and run. So then the question remains, why do we need code? Why do we need high-level languages like Java or JavaScript, which are a lot different than machine code, which are a lot different than assembly, which is still machine instructions, or low-level C, And we see more and more people pick up these languages and be effective with those. Why does the browser run JavaScript instead of C or assembly? Anybody wants to speak up? I would like this to be a discussion because it's about every one of us. Why do we write code? Anyone? Yeah, please. Yeah, it's a structure to create abstractions and to deal with the complexity. And that's right. Why do we need abstractions? Because people are bad at understanding electrical signals. People are bad at understanding machine code. This is a human problem. We write code for humans to understand. We write code for humans to maintain, to build upon. It's not for the machine. It's not for the compiler. It's not the best for the compiler either. JavaScript is not the most performant language in the world, right? But it's one of the most easiest languages to pick up, to learn. And that's why so many people can pick it up and be productive with it. So in the end, writing code has nothing to do with producing applications. Writing code has nothing to do with putting your thoughts into a device, into a phone, a tablet, or a PC. It's all about communicating about the implementation of that application with your colleagues, with your coworkers, so that you write something that both the machine can parse and run, but also your teammates can understand and build on top. That's why we have software architecture. That's why good software architecture is a lot different than what you write personally. You can understand your personal code, but it's probably really hard for your colleague to understand it. So we have design patterns so that we can communicate about code. We have architectural documents. We have UML diagrams. And we use these to make sure people can build on top of our work. Is there anybody here who feels stranger to the code they wrote 6 months ago? Like you don't understand it anymore. You don't know what goes in there. Yeah, that's all right. That's not a shame. Everybody does that. I also do that. I feel very different, very strange to the code that I wrote a year ago, 6 months ago. I can't understand that. That must be somebody else who wrote it. And if I have this level of difference within my own self, think about how different it is for your teammate to understand your code. That's why we need software architecture, and that's why we write code again. So let's talk about the properties of a microservice architecture, or properties of microservices. So the best practices is microservices are able to communicate autonomously. They discover each other automatically. Now you ideally have 100 services or more in a microservices environment. So if you have 3 or 5 services, it's not microservices yet. The usual cases, you have a lot of them. So you cannot do IP configuration, port configuration, or anything of the sort manually. You cannot assign ports or domain names to individual services. It has to be an auto-discovery mechanism, because each service will have multiple copies, and there's no way that you can manually configure them. It has to be zero configuration. It has to be auto-discovery, so that when you release them, when you push them to the live environment, they find each other and start communicating with each other. They also need to be highly redundant. Probably you're running them on a server farm, like 20, 30 servers, and they will fail. Data centers will fail. Services will fail. You'll see a lot of bottlenecks. So you should be keeping redundant copies of each service so that your operation doesn't suffer from this. Your application doesn't suffer from this. It also has to be fault tolerant. If you think about a payment service, for example, in an e-commerce application. Anybody here who does e-commerce applications or who did e-commerce applications in their past? Well, only a few people. The rest are very lucky. It's really hard to work with. So you have a payment system in an e-commerce application, and there is some load. It depends on PayPal, and PayPal is slow to respond, okay? Let's think of the scenario. And your services will slow down. Would you prefer to lose the catalog, the product catalog of part of your application as well? Like, just because some people cannot do payments, just because PayPal is slow, you shouldn't lose your inventory. You shouldn't lose your customer reviews, your product catalog. They should function as independent, separate units, so that there is a fault. If there's a fault in one of the systems, the rest of the system is not affected. So we call this fault tolerance. And the next step is self-healing. They should, basically, your services should be healing themselves. If they go offline, a new service should come up to take their place, so that, again, there is a continuity of the service. And all of these should happen automatically without any human interaction. So this is a very quick intro to microservices. But the idea is, this is all about decoupling. Okay? Decoupling means taking a system that is intertwined, that is bound together, and removing the parts apart from each other, so that the medium inside is something that you can manage, something that is really clear. And this is all about modular systems. And this is not only pertinent to software engineering, but this is how systems are built from the ground up. Like, if you think of electric circuits, they are all using resistors, capacitors, some chips. They're all components, right? And you can bring them together in various different forms, and you can make very different applications from the same components. That is the idea of modular design, and it's been incorporated into everything, and software engineering is no exception. We have to do modular code. And microservices is basically currently, let's say, the best way to ensure decoupling, so that your services are really independent from each other. Your payment service has no idea of your product service, so that you have all the benefits of decoupling. And we know this is really hard to get, right? In a monolithic system, when you have direct access to a product database from a payment service, you will definitely access that database, because it's a lot easier than talking to the guy who is doing the product service. And microservices need DevOps. Basically, these terms are hand in hand. And DevOps enables individual development. It enables individual technology choices, so that one service can be developed independently from the other. It can use another database. It can use another technology. It can use another language. And basically, nobody dictates a single global language to be used within your application, which increases your chances of finding more people or using the best tool for the job. It also encourages individual builds, so that your system doesn't build as a whole at the end of the month, but every time you're releasing code, you're going to production, basically. And it also means individual deployments. Again, some parts of your system will evolve faster than the other parts. So you should be only deploying those changed, smaller parts. And also, in the end, you have individual scaling. Maybe there's a lot of load in the product service, because maybe it's Black Friday or something, so people are browsing your site. You can only scale those product or catalog service, so that the rest of the system doesn't use a lot of resources while you scale out. But there is a pattern here, especially the pattern that everything starts with the word individual. Can you see that? Why is this? This is not a technology choice. This is all about making peace with the actual fact that we don't want to communicate. We don't want to communicate with the developers responsible for another module. We don't want to communicate with the infrastructure managers who are managing servers. We want to be independent of them. Whenever we write code, we want to ship it. We want to see it online as fast as possible without the interruption from anyone else. So organizations tried these waterfall approaches, these agile, Scrum, whatever, for years, and it just didn't work out, because developers, they don't want to communicate. They want to do their own job. I see a lot of smiling faces. Raise your hands if you don't want to communicate. And it's okay. It's just okay. It's okay, right? So this all boils down to something called a power struggle. Who has power over a piece of code that you write? And you want to define those people who have power over that. You know, who can release that, who can run that, who can monitor that, who can maintain that. You want to have that power in your hand. This is like a lion marking their territory. You say, hey, this is my territory, okay? This is my thing. I'm going to do whatever I want. I don't have to reply to any one of you. I don't have to talk you into choosing a different database just because it's better, but you don't understand it. I will do whatever I want. Now, who is born after 1980? So who is less than 38 years old? Raise your hands. Yeah, a lot of people. So this is called Generation Y. If you know that, there's a name for each generation that spans 20 years. And people who are born after 1980 until 1995 or something, they're called Generation Y. And this is actually the problem of, or the operation mechanism of Generation Y. There's a certain reason for why it's called Y. Can anybody tell me why Generation Y is called Y? Please? No, it's all right. Anyone else? Please. It comes after X, yes. Do you know why Generation X is called X? Because they don't want to be defined. X is a variable, right? It's a default variable. Generation X didn't want to be defined. People tried to define them. People tried to dictate their lives. They didn't want to be defined. Generation Y comes after X, but there's another pattern. And I guess you'll recognize it. We want to know why. We ask the question, why? You know, there's a rule called 5 whys. It's used kind of in agile situations to find the root cause of a problem. You have to ask why 5 times. You don't have to tell Generation Y to do that, because they already do. They have to know the exact reason for why something is happening. And so there are a lot of studies, of course, but Generation Y is also referred to as millennials. And millennials have different mindsets from the other generations. So they are right now within the organizations, within the workforce, which means we have to cater to them. We have to build our organizations and our approaches around the psychology and the behavior of the millennials, which are most of us here today. So the thing is, they want to identify themselves with the product they are building, with the company that they're working for, and they want to find a meaning in what they're doing. That's why you see they're leaving their jobs at Netflix, Google, Uber, whatever, and then go and found their own companies. They build their own companies for a reason. They want to be in charge. They want to know the source of the why by not asking the questions. Because if they're doing it, they exactly know why, right? There's no need to ask questions. And this is also about building their boundaries, their peripherals and perimeters. And one thing that organizations are struggling with is product definition, for example. And they, product managers, designers always complain about developers messing with the product, right? They say, you didn't implement it the way I wanted it, or I don't want to hear your opinions, I'm the product manager. And the developers have a very hard time because they want to contribute positively to the products that they're building. And this is also because of this generational behavior. And if you don't give them the power to be effective while they're defining their work, they just leave your company. It's why currently in startups, the average tenure of an employee is 11 months. That means people leave the company that they're working for after 11 months. That's on average. And the biggest reason is they cannot identify with the technology choices, with the culture, and they want more. And the thing is, they have a sense of ownership, or let's say we have a sense of ownership, right? And they don't want to be bound by decisions made by other people before. I'm an enterprise, I'm using Oracle. I have a lot of money, I pay them millions of dollars, and you as a young software engineer, you have to use Oracle DB. Or I'm an open source believer, I'm using PostgreSQL, and you cannot use anything else. Why? Where does that come from exactly? And they want to know why, and they want to grow, because there's a huge fear of missing out. Did anybody hear of that before? Fear of missing out? Yeah, it's like, you know, there are people around you that are doing cool stuff. Yeah, and we think that we are missing what they are doing, because they seem to be having a lot of fun outside doing cool stuff, and we are missing out. We're not part of them. So this is a fear that's growing inside ourselves. Therefore, we want to try the new shiny stuff. We want to try the new database, the new front-end framework that came out, because we don't want to miss out. We don't want to be that weird guy that's standing in the corner all by himself. We want to be part of the cool hype. And we want to grow. And we don't want this to be bound by others, like our managers. Information age, right? We're in the information age. There's a constant stream of information coming in. We read blog posts, and we're always on the lookout for better approaches, better solutions. And most of the time, yes, they're really better than what we're doing at our current jobs. That's why we have a lot of problem currently working in our jobs, and that's why we want autonomy. And that's where this comes from. So let's go back to microservices. Microservices is not a technological choice. It's basically an extreme form of good architecture, which is meant for humans again. So these are some quotes from the book Clean Architecture by Bob Martin, Uncle Bob. That's a very, very good book. If you didn't read that before, I definitely encourage you to read it. That will shed a lot of light. It says that a good architecture makes a system easy to change in all ways that it must change by leaving options open. This matches 100% with microservices, right? Because whenever there's a new change in a system, you can introduce a new microservice. That has nothing to do with the rest of the system. So you are not bound by any of the choices other people did for you before. You don't have to maintain old code. If there's anything new, a new requirement, you can build a new microservice. If there's a new, better approach of doing something, you can rewrite your existing microservice very easily. So that's a good architecture. And in good architecture, teams don't have to interfere with each other. They don't have to communicate, because everything is laid out for them. Everything is basically straightforward. And they're isolated. They are basically component-based modular systems. Again, microservices is the best way to enforce this. Who knows about domain-driven design? A lot of people here. It is actually a software architecture. Microservices is not. But domain-driven design is software architecture. And it was kind of the best way to modularize our code base and our application. But there were no ways to enforce that. And microservices goes really good with domain-driven design. And it's the best way to enforce this notion of modular design, because your applications live in, your microservices live in separate applications on separate servers. There's no way that one microservice can contact the database of another microservice. It's banned, it's blocked. But what do? You read the README of the other service, and you can only use its API, whatever it exposes to you. So it enforces a clear separation between different modules. And finally, if you can modularize your code, you can deliver them to different teams, and different teams will be able to work on them separately and release them separately, all those different modules, like invoicing, payments, category, inventory, user management, access management, profiles, social connections, deliveries, everything. They could all be different modules for different teams to work upon so that they don't have to communicate. So how can we succeed with microservices? I try to underline something. This is a psychological thing. It has everything to do with how your teams operate, how they feel while they write code. And if you want to retain your employees, if you want to retain your team so that they stay with you for 2 years, 3 years, or whatever, you have to build a culture, an engineering culture that supports them. And it starts with giving them autonomy. And you have to observe really well both your colleagues, your managers, or your team members, and build a structure that supports it. Build autonomy within the core. There is no micromanagement anymore. The manager doesn't really know what anybody is doing. They can see the results. You can have a lot of dashboards that give you a green check marks, and that's great, but you don't know what the teams are doing in their day-to-day operations. Because you decide to create a new team, they decide to use a technology that you don't know, and they want to own that part of the product. So you have to give them space, you have to give them the idea, the feeling of ownership, otherwise they won't stay with you. So if you are coming from an enterprise, it's really hard for you to implement microservices. It's extremely hard because nobody wants to give the release buttons to the developers, right? They want to have release managers, dedicated release managers who do versioning, who keep different versions of your application intact, who write huge documentation, and who has the power to click that release button to production, and they don't want to share that power. This is a huge problem for teams who want to adopt microservices. And the most important part is, despite what we have talked about, communication, you have to double down on communication. Now, microservices means that there are two separate or several separate applications, minor, very small applications, communicating over the network to prepare a response to the client, right? The client wants to buy something. What do? You have to check the inventory if you have enough products. You have to check the delivery. You have to check taxes. You have to prepare an invoice. You have to prepare tracking the shipments. And you have to prepare an order and send it to the customer. You have to validate their credit card information and charge the amount from their credit card, right? These are all separate tasks. So all of these are happening with communication from different microservices. So the microservices are themselves communicating heavily, which means if you go back to the first slide, if you are using microservices, which relies on heavy communication, your organization scheme also should be around communication. You have to have teams who are in constant communication. And I'm going to talk a little bit more about that in the next slide. But first, again, microservices, although it looks like a technical solution with deployments, with technological choices, etc., it's not. It's basically a solution for collaboration because, again, we don't want to communicate, we don't want to talk, we don't want to collaborate with anybody. We want to be left alone. Or at least within our inner circle, you know, within our team of 3-4 developers, we want to be left alone because they are the people whom we can communicate with the best. But the thing is, microservices is very efficient at decoupling your communication from your implementation, which means your implementation, your code, right? It doesn't have to be in the exact same way as you communicate, or the problems of communication that you have should not affect the code that you write. You write your code, your domain, your product, your service on your own without communicating with other parties, and it will still work. Whereas on the other parts of the system, or before microservices, you had to have very strong communication with the database team, with the UI team, or with the product catalog team, because you're messing with their database. And this is where the problem comes from. So it decouples communication from implementation. Communication happens at another level for other stuff, and implementation, writing code and delivering value, happens on another level. And here's the most important bit. Communication is not only about talking. So there are hundreds of different ways of communicating with people, and talking is only one of them. So the best form of communication that I found that works for teams and distributed teams is documentation, for example. Because think about it, we're used to doing an npm install, and we're used to looking for repositories on GitHub and checking their readmes, and using the examples, using the blog posts, and doing our job with that, without being dependent on anyone else, right? We want to do that at work as well. So the idea is every team responsible for a microservice comes up with a documentation as simple as a README to tell how that system is being used or how that system should be used. What are the responsibilities of that system? What can you do if you make use of that system? What it is good for? Like a blog post with examples, or like an open source library README. And that is the best form of communication that happens asynchronously. You write once, you don't have to tell anybody again. And you have the exact power to change, or you have the absolute power to change that documentation or that functionality. No one else can mess with your code, with the functionality that you wrote. So other people at other times, 3 years down the road, in other parts of the company, can basically look into your code, look into your module, your microservice, look at its documentation, and without you being present there, can make use of that. This doesn't happen in regular source code where you have classes and you have interfaces that everybody is using that's all over the place, and you have a lot of time, a hard time going through code with command clicks or control clicks, whatever, to see where this will lead, where does the rabbit hole end. So the thing is, you have a right team setup. You have to give them ownership. This is your responsibility. You're responsible for this product, for this feature, and you build every piece of that feature. And so you also basically leave no room for interpretation. There are a lot of ways to use a class. That's why private properties were invented in class-based languages, because people were messing with the internal operation of that class. So some people said, okay, this cannot happen. I will mark some fields as private so that people who use this class will not be able to see those private members, whether they're properties or methods. They will not be able to use that. So I have at least some freedom, some space within my class. So and then we came up with the idea of interfaces and said, you shouldn't depend on my concrete class, depend on this interface, because I guarantee that the interface will not change. Now, these are all good attempts at decoupling software, but the best attempt is to create a library, a separate module that only has a REST API interface, for example, and there's no other way that you can make use of that software. And therefore, basically, you minimize the frustration that your team members would have, because they're not sifting through code. They don't see their the classes guts spilled all over the place in your application. It's contained in one place, and it's known what it can or cannot do. And lastly, you have to change the mode of ownership. Previously, we had teams that are responsible from databases, right? Or people that are back-end engineers who are responsible for building the business layer, the business logic, functionality of the code, of the domain. And we had the infrastructure people, the sysadmins, system administrators. Anybody remember sysadmins? Yeah. That was a very weird era. And we're moving away from that with DevOps. Because you have to own what you write, and you have to own what your code runs on. You have to own the infrastructure as well. But previously, it was a separate team. Previously, there were database administrators who are very good at optimizing the queries that you write for the machines, for the SQL engine. But it's horrible to develop on that, because they optimize to a point that you cannot understand it anymore as an application developer. So you cannot build on top. There were front-end engineers for the UI, who are building either a mobile application or a web page, the UI of the feature that you have to build. Therefore, whenever you wanted to introduce a new feature in your application, you had to go to the infrastructure layer to see that you have available server resources. You had to go to the database administrators to have them implement the database. The back-end engineers and the front-end engineers, they had to work hand in hand. This is a lot of communication, and this is why we failed for most of the time, because we don't want to communicate again. So the mode of ownership has to change, and what it will become right now is that teams, individual developers or teams, will be responsible for a thin slice through these layers of software, infrastructure, backend, database, backend, frontend. A team will be responsible for a thin slice of this, which means they will do the infrastructure themselves, they will build the database themselves, they will build the backend code and the front-end code themselves, either as a single person or as a team. And they will clearly identify the boundaries of that feature and the interactions of that feature. You know, this is a shopping cart. You can add items to this shopping cart, you can remove items, and that's all we do. And here's the API for that. Use that API, you'll get a nice shopping cart. That's all. Give us a user ID and a list of products. This is how we expect them in JSON. And then, you know that your shopping cart works, and you give the ownership of that shopping cart to a team, and then that team can go out and say, yeah, I built that cart myself or with my team, so that they can identify themselves with the product. They have a strong connection to the product. So this is a huge chance for full-stack developers. Who is a full-stack developer here? Some people, yeah? It's growing, I guess. Who wants to be a full-stack developer? Less. Okay, that's interesting. You should think more about that. Who is writing JavaScript? Okay. If you're writing JavaScript, this is an immense opportunity for you, because with JavaScript you can do the backend, the front end, with MongoDB, the database itself. The application, if you do hybrid applications or React Native applications, you can do all parts of the stack and you can deliver features. So this is an immense opportunity for full stack developers or JavaScript developers who can or want to be full stack developers. And this is also why JavaScript is so popular with Generation Y, the millennials, because they don't have to report to anyone else. They don't have to depend on the database administrators or the backend engineers to deliver some code. Beforehand, we had integration meetings between the front-end teams and the backend teams, because they worked on it separately, they worked on the feature separately, and then they came together to identify the JSON exchanges. And this didn't work. Like, these meetings took forever, and it meant a definitive refactor both on the front end and on the back end to make sure that they can integrate over a set of JSON data. And with JavaScript, with Node.js, and the front-end frameworks, you basically eliminate this. So it gives power to you as a developer. So let's conclude with the beginning again. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And communication is a direct byproduct of human nature. So everything will evolve with your communication. Communication evolves with the humans, as each generation has their own properties or has their own way of communication. Your structure, your code, your organization has to evolve. And if you look at microservices as only a technological choice, you'll definitely fail. It's a cultural shift. It's a communicational shift. And in order to succeed with microservices, you have to consider the human side of microservices. Thank you. Guess we have a couple of minutes for questions. Anybody? Okay, I'll be here throughout the rest of the day, so we can talk whenever you like. Thanks again for coming.